Alright, let's talk about one of the real visionaries of AI convolutional neural networks, or CNNs for short. If you're into AI, you've probably heard the term tossed around, especially when it comes to computer vision or image classification. But what actually makes CNNs so special? Let me break it down in a way that just clicks. Imagine you're trying to recognize a friend in a crowded room. You don't scan every pixel of everyone's face. Instead, you look for patterns, maybe the curve of a smile or the shape of their glasses. CNNs work in a similar way. They're designed to process grid-like data, like images, by picking out patterns and features automatically. Here's how it works. At the base level, CNNs use what are called convolutional layers. Think of these layers as a set of smart filters that slide over the image, looking for simple features like edges, colors, or corners. As you move deeper into the network, the layers start combining those simple features into more complex shapes like noses, eyes, or wheels. It's a bit like how our own brains start with simple lines and build up to recognizing entire objects. It's pretty wild how close that is to biological vision. Now, CNNs don't just stop there. They've got pooling layers too, which help by summarizing or downsampling the data, sort of like zooming out and keeping only the most important info. This keeps the network efficient and helps it focus on the big picture. And finally, there are fully connected layers. These act like the grand finale, taking all the features the network's learned and making the final call, whether that's deciding if an image has a dog, a cat, or even a tumor. But here's something really cool CNNs are tolerant to where things show up in an image. Whether your cat's in the corner or right in the center, CNNs can spot it, thanks to the way they share weights and biases across layers. That means they don't have to relearn what a cat looks like every time it moves. So, what can CNNs actually do? The list is almost endless. They're used in self-driving cars to detect pedestrians and traffic signs, in surveillance systems to identify faces or suspicious objects, and in robotics to help machines see the world around them. In medicine, CNNs look for early signs of disease in scans that even doctors might miss. They're also the magic behind your phone recognizing your face, or your voice assistant picking up on "Hey Siri." All of this is possible because CNNs learn features hierarchically, starting simple and getting more complex with each layer. They don't just crunch numbers. They build an understanding, piece by piece. That's why they're so good at handling variation, different lighting, angles, or even noise. So next time you see a computer flawlessly labeling images or identifying objects in a video, remember there's a CNN working in the background, seeing the world in ways that are surprisingly close to how you and I do. That's the visionary power of convolutional neural networks.